Hey students, let's get to work. This is 8th grade math, unit 3, lesson 6. Problem number 1. Look for a growing pattern. Describe the pattern you see. Okay, in picture 1, I'm going to call this n equals 1. We have 1 yellow square, 1 red square, and 3 blue squares. Okay, when n equals 2, look at this. The yellow squares are squared. And the red squares are just adding one more, I guess. 1 plus 1 equals, now there's 2, so they just added one more. How about these blue squares? 1, 2, 3, 4, 5, 6 of them. It's doubled. They went from blue equals 3 to blue equals 6. You know what? I have an idea. Let me change the color of my pen. There we go. So here in the first picture, n equals 1, we have 1 yellow square, and we have 1, 2, 3 blue squares, and we have 1 red square. And then when n equals 2, we have 2 times 2. We have 2 times 2 of these yellow squares, 2 times 2, and we have 1, 2, 3, 4, 5, 6 of the blue squares. So that got doubled. And then 1, 2 of the red squares. So it was red was plus 1 more. Look, when n equals 3. Now what do you see? We have 3 times 3 for the yellow squares. We have 3 times 3. And then count the blue squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. For the blue squares, we have 3 times 3. And for the red squares, we have 1, 2, 3. It just equals the n, the 3 there. 1, 2, 3. So, okay, do you recognize any pattern here? I see a pattern. Problem 1a. If your pattern continues growing in the same way, how many tiles of each color will be in the fourth diagram? Okay, let's just draw the fourth diagram. So it's going to have, if this is the yellow, let me write here. So yellow equals some number n times itself, n squared. Yellow equals n squared. And blue equals n times 3. If n equals 1, this is 1, 2, 3. So that's n times 3. And then for the red squares, it's just n. Whatever this n is, it's the same as n. Red squares equals n. So if it's going to be the fourth diagram, then let's add one more here, one more square here, and one more square here. Like that. We can see the growing pattern. And then there's going to be 3 more blues. 1, 2, 3, because every time it increases by 3. See? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Every time the blue increases by 3, and the reds increase by 1 more. So that'd be like 1, 2, 3, 4. Well, it's going to be like that for the red squares. Okay, so let me draw that. It's going to be like this, and this is going to be a 4 by 4 square, and this is going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. And then this is going to be 4. 1, 2, 3, 4. Like that. Okay, my picture's not that good. So how many tiles of each color? Well, the red is going to have 4 by 4. So red is 4 by 4. That's 4 squared. Oh, I'm sorry. I said red, but I meant yellow. These are going to be the yellow ones. Let me back that up. So how many yellows? They are going to be 4 squared because n equals 4. And for the blue, it's going to be 3 times 4 because they are in sets of 3. So 4 times 3 equals 12, but anyway. And then for the red, that's just going to be equal to whatever our n is. In our fourth case, red will have 1, 2, 3, 4 squares. So red is just 4. All right, good. If your pattern continues growing in the same way, how many tiles of each color will be in the fifth diagram? Okay, well, yellow is squared, so it's going to be 5 squared. Blue, those are in sets of 3, so that's going to be 5 times 3. And the red is going to be just equal to whatever our sequence number is, 5 in this case. You can draw it if you want to. Okay, next question. If your pattern continues growing in the same way, how many tiles of each color will be in the 10th diagram? Okay, so we're going to, the yellow blocks is just a square, sorry. So that's going to be 10 times 10, or 10 squared. Look again, the blue box are in sets of 3, and every sequence adds 3 more. So for blue, it equals 10 times 3. And then the red blocks is just increasing by 1 every sequence. So that's going to be red equals only 10, whatever our sequence number is. Question 1D. If your pattern continues growing in the same way, how many tiles of each color will be in the nth diagram? Now, n, have you seen that before? I used it from the start. That's just some counting variable. N equals 1, n equals 2. We're just counting what our sequence is. N equals 4, n equals 5. So go on forever. And when we say nth, we mean some nth, whatever it is. Just keep on going. Well, whatever n is, we can find that the yellow blocks, which is just a square, is going to be n, whatever n is, squared. So if n equals 20, it's the 20th sequence, then it's 20 squared. For the blue blocks, it's a multiple of 3. They're going in sets of 3. So that's going to be n times 3. Whatever n is, it has a set of 3. And then for the red blocks, that just is increasing by 1. N equals 1 is 1. N equals 2 is 2. N equals 3 is 3. So that's just going to be equal to whatever n is for our sequence. It says explain how your reasoning. Oops, I think it means explain how you know your reasoning. Well, I can see that. Hold on. I'm going to explain it. Let me help you with this explanation. I'm pretty good at putting this into words, so I'll help you. I can see that the yellow blocks form a square, and the blue blocks are in multiples of 3, and the red blocks just increase by 1 each time, each n. Yeah, for each n. I'll put it that way, for each n. There we go. Okay, I can see the yellow blocks form a square, and the blue blocks are in multiples of 3, and the red blocks just increase by 1 each n. All right, good job, guys.